Okay, up here, class. Shh. Okay, so today we're learning about segments and triangles. So we need a bunch of definitions. Okay, an altitude. An altitude is a line segment through a vertex and is perpendicular to the opposite side. You would also know it as a height. The height of the triangle. A line segment through a vertex and is perpendicular to the opposite side. So we would say if DB, segment DB, is an altitude of triangle ADC, then DB, segment DB is perpendicular to segment AC. So the biggest thing when you're looking at an altitude to determine if it's an altitude or not you need to have it come from the vertex and it has to be perpendicular. It has to have a right angle. Okay, that's what we know. If I tell you altitude, you should think right angle. Okay, a median is a line segment joining a vertex to the midpoint of the opposite side. A line segment joining a vertex to the midpoint of the opposite side. Okay, so we would say if DB, segment DB, is a median of triangle ADC, then AB, segment AB would be congruent to segment BC. Then AB would be congruent to BC. Bisector of angle ADC then angle ADB would be congruent to angle BDC. Again, with this one, for you to be able to determine if this is an angle bisector, you need those congruency marks to show that those two things are congruent. Any questions over that? We're good? Okay, perpendicular bisector by side. Okay, we've already talked about perpendicular bisectors yesterday. Now you're gonna have a perpendicular bisector of a triangle. And it's a line segment that is both perpendicular and passes through the midpoint of one of the sides of the triangle. A line segment that is both perpendicular and passes through the midpoint of one of the sides of the triangle. Okay, so we would say if segment BE is a perpendicular bisector of segment AC, then BE segment BC is perpendicular to segment AC, and segment AB would be congruent to segment BC. Okay, and again, to show that, you would need to have your right angle and those congruency marks. You need both of those to say it's a perpendicular bisector. Okay, we've also already discussed mid-segments before. Okay, a mid-segment is a segment connecting the midpoints of two sides of a triangle. Mid-segment is a segment connecting the midpoints of two sides of a triangle. Okay, so that would be if DC, segment DC, is a mid-segment of triangle, triangle AEB, then DE would be congruent to AD, and EC would be congruent to CB. Okay, next one. Mid-segment theorem. Mid-segment theorem. The mid-segment of a triangle is half the length of this third side and parallel to the third side. Okay, so just like yesterday when we had the perpendicular bisector and then the perpendicular bisector theorem, okay, there's also a mid-segment theorem. So the mid-segment theorem is the mid-segment of a triangle is half the length of the third side and is parallel to that third side. Okay, so we'd say if segment DC is a midsegment of triangle A, E, B, then DC is equal to 1/2 the measure of AB. Or you could say AB, the measure of AB, is equal to 2 times DC. Any questions over that? Okay. And finally, DC would be parallel to AB, that third side. And again, for those marks, for both midsegments, you would need to show these sides are congruent to each other and these are congruent to each other. Same on the other one. The two sides are congruent. It cuts it into 2 congruent parts. Okay, any questions over that? We're all good? Okay, now using those 2 triangles, you need to identify an angle bisector, a median, an altitude, a perpendicular bisector, and a midsegment. Everyone try and label that for me. And BF, and you can name it the other way, FB, that's fine. You just put BF with a little line above it, or FB. Okay. Ryan, what'd you get for the median? Okay, so H can't be HE. It has to go, look at the median here. It has to go from the vertex to the opposite side. AE. So it has to go all the way from A to E. And again, you can do it the opposite, EA. That's okay. Vertex and be perpendicular. Perpendicular bisector, QK. Congruency mark, so M. Or MN, whichever. Okay, so that was identifying them. Now, can you tell me what it means? If I tell you it's a median, what does that mean? Okay, so given J, so here's a median. I go back to my figure. Oopsie. Okay, any ideas? Very good. Okay, so we're going to walk this through step by step because we have to explain why. So if PM is 12, that means that ML also has to be 12. Okay, because they're congruent. Okay, those 2 pieces are congruent. 12 plus 12. So PL is equal to 24. And the reason for that is our segment addition postulate. The 2 parts equal the whole thing. And is it at points? The segment theorem is my y. So I can say that this is a midsegment. NM is a midsegment. My reasoning would be midsegment theorem. Okay, that would be the reason why. because I have parallel. The mid-segment is parallel to the third side and half the distance. So that's the mid-segment theorem. So now how could I set up my equation? How is 2x minus 4 related to 16? Are they equal? It's half of 16. Okay, so we would have that 2x minus 4 is equal to half of 16. Because these two pieces are congruent. This is congruent to this. So each piece has to be 8. So then we just solve it. 2x minus 4 is equal to 8. Then we add 4 to both sides. And we get 2x equals 12. Divide by 2, divide by 2. And I get x equals 6. Any questions over that? And the reason for the equation, I could say the definition. So the second reason would be the definition of mid-segment. Because the mid-segment tells me that my sides are divided into 2 equal parts. Okay, so given AC is an angle bisector. Let's go back up and look and see what that means. Okay, a ray that divides the angle into 2 congruent parts. So my 2 angles are congruent here. So I know that this is going to be congruent to this. It also tells me that the measured angle D is 56 degrees. And the measured angle B is 68 degrees. Any ideas on how I can find the measured angle D, A, C? Very good. I can find the bigger angle first. I can find that big angle by using the sum of the interior angles. So it'd say the measure of angle DAB plus 56 plus 68 is equal to 180. So I'm going to combine my like terms, get the measure of angle DAB plus 124 equals 180. I'm going to subtract the 124. And that's going to give me the measure of angle DAB is equal to 56. So the big angle is 56 degrees. Okay. And the reasoning right there was the sum of the interior angles of a triangle. Okay, some of the interior angles for a triangle equals 180 degrees. Okay, now we just need to find the measure angle DAC. So the measure angle DAC is going to be equal to half the measure of 56. So the measure of angle DAC is equal to 28. And how do I know that? Yeah? Very good. The definition, so our second reason was the definition of angle bisector. Any questions over that? We're all good? Okay, next. I want you guys to do that one in your pairs. Things if we didn't already, because that was marked wrong. So we should have the 3 plus 6 should be equal to 2 times 12, because it's bigger. It's twice as big as 12. So 3x plus 6 should be equal to 24. Then we subtract 6. We get 3x equals 18. Divide by 3, divide by 3. We get x equals 6. Okay, our reasoning why. We have to decide. In just 1 second. Is it the mid-segment or is it the mid-segment theorem? Very good. The mid-segment talks about the sides being half of each other. The mid-segment theorem talks about the middle pieces being half as big or twice as big. Okay, so we have to use the reasoning for the mid-segment theorem. So the reason is mid-segment theorem. Any questions over that? Okay, next one. It says given BC. Did you get it down? Yeah, okay. Given BC is an altitude. Okay, I need to go back up and see what an altitude means. Okay, here's an altitude. It's from a vertex, the opposite side, and it's perpendicular. So it's a right angle there. Okay, so I'm going to draw that in. Perpendicular and right angle is the same, right? Perpendicular lines mean right angles. Okay, so BC would be perpendicular to AD. Segment BC is perpendicular to AD. And they want us to find BD. So that very first reasoning, why can I say they're perpendicular? What?
Altitude.
The definition of altitude. Okay, the definition of altitude. Okay, that's how I know it's a perpendicular line. Now, how can I find x? Oh, yay. It's a right triangle. So I can use the Pythagorean theorem. I can say 6 squared plus 3 squared equals the hypotenuse squared. So 36 plus 9 equals x squared. Combine the like terms and get 45 equals x squared. Then I square root, and I get x equals 6.7. Okay, and that reasoning is the Pythagorean theorem. Any questions over that? Okay, next one, last one. Okay, ED is the perpendicular bisector of triangle ABC. Find AD. So I'm going to go back up. Maya. I'm going to figure out what a perpendicular bisector is. Okay, it is perpendicular and it passes through the midpoint. So I have a right angle and congruent sides. Okay, so I'm going to go back down and I'm going to mark that. It's a right angle, and this is congruent to this. So DE is perpendicular to AC, and AD, segment AD is congruent to segment DC. Okay, and that, again, what's the reasoning for that? Definition of perpendicular bisector. I'm going to abbreviate perpendicular bisector. That's what that means. Now we want to find AD. Any ideas? Good, I can find DC, right? Which is the same as AD. So again, I'm going to use the Pythagorean theorem. I'm going to say 6 squared, this time plus the x squared, is going to equal the hypotenuse squared, which is 9 squared. So 6 squared is 36 plus x squared is equal to 81 minus the 36. X squared equals, so weird, 45. I square root. And what does x equal again? 6.7. So that means that AD is equal to 6.7. Measure of AD. Okay, and what's the reason why there? Pythagorean theorem. Pythagorean theorem. Any questions over that? Okay, your homework is in your packet.